Okay, so in this video, we are going to talk about loan with other repayment pattern. So we talk about constant repayment loans in the previous two videos. And in this one, we are going to talk about other repayment pattern loans. Okay. So here's a question. So for this kind of questions, like when you have a loan with other repayment pattern, it's depend on the question which kind of methodology you are going to employ. So because of that, we are going to use examples to show you how to solve this kind of questions. So the question says, Beatrice takes out 20,000 loan for 10 years at level annual effective interest rate of 5%. Her original payment is P, and then her payment increased by 200 each year. So right away, you can see that now this is more like arithmetically increasing annuity, the ones we learn in annuity section. So we are going to apply that knowledge to this section. So here it says 20,000 loan for 10 years at level annual effective rate of 5%. So let me draw the timeline. So here is 0. 10 years. So we have 1, 2, we have 10. Rate is 5%. And the original balance is 20,000. Rate is 5%. It is annual effective rate. Okay, so I is 5%. And her original payment is P. So this one is P. And then her payment increased by 200 each year. Find P. So this one will be plus 200. And this would be what? P plus 9 times 200. Okay. So we want to find the payment fee. So this is, even though it says a loan, you can right away see this is really annuity problem. So how do you find P? You take the discounted values of these cash flows. So basically this one multiplied V, this one V square, this one V to the 10, and you need to make it equal to 20,000. So 20,000 equal to what? P times V plus P times 200 times V square all the way up to 3 plus 9 times 200 to the V10. Okay. So this is basically arithmetically increasing annuity. So you can see that if I write what is the percent value of arithmetically increasing annuity? AN, I mean, let me write the percent value. But P Q times N minus NV10 over I, no? So this would be like what? So this would be 0. This one is P. This one is P plus Q. So this is N, P plus N minus 1 times Q, no? So if I apply that in here, Q would be 200, N would be 10, V would be what? V would be 1.05 to the negative 1, I would be 5%, N is 10, so P is what you want to find. Percent value is actually given is 20,000. So you can basically apply that. You can apply your knowledge from annuity and find the answer. So I would stop here, but you can continue and try to get the answer for P. Method is right there. It's basically arithmetic progression annuity. So here's another one. Cedric take out 20,000 loan for 10 years at annual level rate of 5%. His payment grow by 20%. So right away, you can see the previous one is arithmetic progression. This one is geometric progression. So this is geometric progression annuity. Okay. So what you need to do, you have to use the formula for geometric progression annuity and find the amount of first payment. Okay. So if I draw the timeline, it will look like what? This is 0, 1, this is 10. Let's say this is P, and this would be P times 1.2. Next one would be P times 1.2 to the square. This one would be P times 1.2 to the 9. And then here your balance is 20,000, and you can take the discounted value. So you can see B0, which is 20,000, should be equal to present value for this cash flow. So PV plus P times 1.2 times V square, all the way up to P times 1.2 to the 9 times V to the 10. And you can see P times V is common factor, 1 plus 1.2 times V, all the way up to 1.2 times 1.2 to the 9 times V to the 9. And this is at 20,000. And V is 1.85%. So 1.05 to the negative 1. And basically you can now solve. So this is geometric series, sum of geometric sequence. So you can use the formula and get the answer. So I will stop you again here, and please continue and get the answer. So here's another one. So when you make a loan, when you repay the loan, usually, yes, you have the first n payment, n minus 1 payment at level, but then the last payment, it can be either lower than what you used to pay or bigger than what you used to pay. So it called either drop payment or balloon payment. Okay. So if the final payment is bigger than your usual regular payment, it is called the balloon payment. If the final payment is smaller than your usual regular payment, it's called the drop payment. So balloon payment referred to final payment is larger than the typical payment, while drop payment is smaller than the typical payment. Now, when you read the problem, if it says last payment is balloon payment, then you need to know that the last payment is going to be bigger than what you used to pay. If it says the last payment is a drop payment, then you need to know that last payment is going to be lesser than what you used to pay. So those words you need to understand right away. So here it is. Question. Daphne also takes out 20,000 loan at annual rate of 5%. She makes annual payment that are 4 times the interest due until she can make the final end of year payment of no more than 2,500 to pay off the loan. When does she make this final payment, and what is this amount? So let's try to solve this problem. So here is the timeline. This is 0. So this one would be 20,000. This is B0. And the she's paying what? She makes annual payment that are 4 times the interest due until she can make final end of year payment. So the first payment would be what? So payment 1. So it would be 4 times interest due. So what's the interest due? So 20,000. What's the rate? 5% per year. And then 4 times. So what is that? Let's calculate this. So that would be 4,000. Okay. So second payment would be what? So if you remember the mortgage schedule, what's going to happen? So let me draw a mortgage table. Okay. So this is the time 0. This is the outstanding balance. So BT basically, this would be 20,000. And then here I can write the interest due and the payment. Okay. Let me write first the payment, and then the next one is interest due. Okay. So the end of the year 1, this is the end of the year 1. Okay. End of the year 1, the payment would be 4,000. Okay. Because that's a 4 times interest due. Then the interest is what? Interest is 20,000 times 0.05, which is 1,000. So then you are using 3,000. Remember, first you pay from the payment, 1,000 goes to the interest, then the rest goes to the outstanding balance to pay the outstanding balance. So the remaining balance is now 17,000 because you pay the 1,000 to the interest, then the remaining 3,000 you are going to use to pay the outstanding balance. So the end of the year two, what would be the payment? So interest would be what? So interest would be 17,000 times 0.05, which is 850, but you are paying 4 times that. So 4 times that would be 3,400. So then the remaining balance would be 17. So you can see that 3,400 minus 850. That would be 2,550. And then you can take 17,000 minus that. So that would be 14,450. Okay. Let's go to the next payment. So third payment, let me write here. That would be 14,450 times 0.05 times 4. So that would be 14,450 times 0.05. So interest is 722.5. And then the payment would be 4 times that is 2,890. So now your outstanding balance would be 14,450 minus. So out of 2,890, you first pay the interest. Okay, so whatever left over, that's what you use to pay the principal amount. Okay. So it would be 12,282.5. So you can continue this way, and then you can find the. So the question says, so she would continue this until she can make final end of year payment of no more than 2,500 to pay off the loan. So if I go the next one, fourth one, let's see the payment for the fourth one. 2.5 actually, 9.05 times 4. So that would be 2,456.5. That would be the payment amount. So this one says, so then the interest would be what? So interest would be actually 614.125, and then you can find out how much you have left to pay the outstanding balance, and then subtract that from 12,282.5. So I get 10,000. 440.125. So you can continue this way, and then find the find when your outstanding balance is going to be less than 2,500. Okay, so at one point you will have BT less than 2,500. When that happened, that time T, that would be your answer. Okay, and then you can find the outstanding balance. That would be what is the amount, and when does the pay, when does she is going to make the payment. Okay. Let's go to next one. A loan of 15,000 is to be repaid by means of 6 annual payment. The nominal interest rate is 12% compound monthly. Create an amortization for this transaction. So you can create a amortization schedule like this one. So that should be okay. So basically, what you have time, you have payment, you have IT. If you want, you can include the PT, principal amount, and then the BT. Okay. At time 0, it's 15,000. At time 1, payment is 3,719.18. And you can calculate the interest. So payments are annual payment. Okay, the rate is given 12% compound monthly. So it is I12 is 12%. So what you can do, you can calculate interest per year. So first calculate the effective rate. So once you get the I, you can let's find out what is the rate really. 1 plus 12 divided by 12 is 1, so it's 0.1. Okay, so let's see what is the rate. No, 1.0. So your rate would be 12.682502. That's the effective rate. Then the interest due at the end of the year 1 would be what? I1 would be 15,000 times that rate. 12.682503, which would be 1902.375452. Then you subtract that amount from payment. So to see the principal amount, so payment is 3,719.18 minus this, you get 1860.80, and you can use that in here and to get the subtract by 15,000 to get the new outstanding balance, which would be 13,183.19545. So you can continue this. Okay, so that's the end of that topic. We will meet again for the next